Have you ever wondered how your smartphone camera identifies faces or objects, or how self-driving cars navigate through traffic? In this extraordinary age of technology, machines have learned to see and understand the world around us. Every time you unlock your phone with facial recognition or enjoy the convenience of automated surveillance systems, there's a complex process at work. This process, known as object detection, is a fundamental element of computer vision. It's the science that enables machines to identify and locate objects in their environment. From your everyday smartphone to high-tech self-driving cars, object detection plays an indispensable role. It's the silent partner that powers the convenience, safety, and automation we've come to appreciate in our lives. It's the wizard behind the curtain, the unseen hand that guides the machines that make our lives easier. The magic behind these incredible feats is an algorithm known as YOLO, or you only look once. So, what exactly is this YOLO algorithm? Let's unravel this mystery. YOLO, an acronym for You Only Look Once, is a groundbreaking algorithm in the field of computer vision, a domain that enables computers to gain high-level understanding from digital images or videos. Simply put, it's a method that allows machines to identify objects in images or videos, much like how we humans recognize objects around us. Imagine you're looking at a picture of a park. Your eyes scan the image once and you can identify trees, people, maybe a dog or two, perhaps a bench. That's because your brain is excellent at recognizing patterns and objects, having been trained since birth. Now, YOLO aims to bring a similar capability to computers. The magic of YOLO lies in its approach. Traditional object detection methods operate in two steps. First, they identify regions of interest in an image, and then they classify these regions into different object categories. However, YOLO does this in one single pass. It sees and understands the image in just one look, hence the name You Only Look Once. But how does it do this? YOLO divides the image into a grid. Each cell of the grid is then responsible for predicting the presence of an object. It's like each cell is asking itself, is there an object in my little part of the picture? If so, what is it? This way, YOLO not only predicts the presence of an object, but also its class, or what the object is in each grid cell. This seemingly simple method revolutionizes the way computers perceive images, making object detection faster and more efficient. It's like teaching a machine to read an image the way we read a book, from top to bottom, left to right, all in one sweep. Simply put, YOLO helps machines see and understand the world around them. Scene script. Sounds complicated? Not to worry, let's break it down. You might be wondering how exactly this YOLO, or You Only Look Once algorithm, pulls off this magic trick of detecting objects in images. Well, it's all about the process. And it's a three-step dance: bounding box prediction, class prediction, and thresholding. Let's start with step one, bounding box prediction. Imagine you're looking at a scene, maybe a busy city street. There are a lot of things going on. Cars are moving, people are walking, maybe there's a dog chasing a pigeon. Now, how would you begin to describe this scene to someone who can't see it? You'd probably start by outlining where each object is, right? That's exactly what YOLO does. It breaks down the entire image into a grid, and for each cell in this grid, it predicts multiple bounding boxes. These boxes are like frames around potential objects in the image. The algorithm also assigns a confidence score for each of these bounding boxes that reflects how sure it is that the box contains an object. The next stage of the dance is class prediction. Now that YOLO has a bunch of potential objects framed by bounding boxes, it needs to figure out what these objects are. Is it a car, a person, a dog, or maybe a pigeon? To do this, the algorithm predicts the class probabilities. In other words, it's making an educated guess about what kind of object is in each box. It does this based on the features it has learned during its training phase. Finally, we come to the third and final step of the dance, thresholding. This is where YOLO gets picky. It uses the confidence scores from the bounding box prediction and the class probabilities from the class prediction to decide which boxes make the final cut. If a box has a low confidence score, meaning the algorithm isn't very sure there's an object in it, or if the class probability is low, meaning the algorithm isn't very sure what kind of object it is, then that box gets cut. Only the boxes that meet a certain threshold make it through. The beauty of YOLO is that it performs all these steps in one go. It's like a seasoned salsa dancer, smoothly transitioning from one step to the next without missing a beat. This makes it incredibly efficient, and it's one of the reasons why it's such a popular choice for real-time object detection. And there you have it, the inner workings of the YOLO algorithm, simplified. Now, you might be wondering, why is YOLO so important? Well, let's talk about it. The significance of the YOLO algorithm lies in its incredible ability to perform real-time object detection. It's a bit like having superhuman vision, being able to identify and categorize objects in a scene in a fraction of a second. This speed doesn't compromise accuracy either. YOLO stands out from the crowd of other object detection algorithms with its impressive precision. Imagine a bustling city intersection, cars, bikes, pedestrians, dogs, pigeons, all moving in different directions at different speeds. Now imagine having to identify and track every single object all at once. A daunting task, isn't it? But that's exactly what YOLO does, and it does it remarkably well. It's like a symphony conductor, flawlessly orchestrating a complex movement of objects. But why does this matter? Why do we need an algorithm that's so fast and accurate? The answer is simple: because our world demands it. We are hurtling into an era where technology is increasingly intertwined with our daily lives. And YOLO has the potential to revolutionize several fields. Take self-driving cars, for example. These vehicles need to make split-second decisions based on their surroundings. They need to identify pedestrians, other vehicles, traffic lights, road signs, and more. YOLO's speed and accuracy make it ideal for this task. Consider surveillance too. Security systems equipped with YOLO could monitor vast areas, swiftly identifying and tracking any suspicious activity. It could make our cities safer and more secure. And let's not forget about augmented reality. This technology is all about enhancing our perception of the world. And what better way to do that than with an algorithm that can identify and categorize objects in real time? In essence, YOLO is a game changer in the realm of object detection. It's fast, it's accurate, and it has the potential to transform how we interact with the world. So when we ask, why YOLO? The real question is, why not? In conclusion, the YOLO algorithm is a critical piece of the puzzle in our increasingly automated world. It's the magic behind the curtain, enabling machines to see and understand their surroundings, much like we do. This innovative approach to object detection breaks down an image into a grid, each cell responsible for predicting multiple bounding boxes and class probabilities. Its beauty lies in its efficiency, performing detection and classification in a single pass, which makes it significantly faster than traditional methods. This speed, combined with its accuracy, opens up a myriad of potential applications. From autonomous vehicles to surveillance systems, from robotics to augmented reality, YOLO is paving the way for a future where machines interact with the world in ways we've only dreamed of. Next time your smartphone camera identifies a face or a self-driving car maneuvers seamlessly through traffic, remember, it's all thanks to YOLO, the algorithm that lets machines see.